We're going to have a look at reacting masses. Whenever you do a question like this, the first thing you've got to start with is a balanced symbol equation. So let's have a quick go at that. We've got ethanol, which is C2H5, reacting with oxygen in the air. It's burning completely, and it forms carbon dioxide and water. To balance it, we need to do this. We've got 2 carbons on the left-hand side, so we need 2 carbons on the right-hand side. We've got a total of 6 hydrogens here, so we need 6 hydrogens on the right-hand side, which means doing that. And if you look over here, we've got 4 plus 3 oxygens, which is 7 oxygens. One of those oxygens is here, which means 6 need to be here, which is why we're at 3. 3 pairs of oxygen atoms is 6. That's the first step. Step number 2 is to look at what we've got information on, and you see we've got information about the carbon dioxide. And bearing in mind we've got 33 grams of carbon dioxide, from the grams you can work out the molar mass using this. So if you look at this equation here, we've been given the mass of carbon dioxide. We can work out the mass of 1 mole of carbon dioxide using the formula in the periodic table, which means we should be able to get the number of moles of carbon dioxide. So we can say the number of moles of carbon dioxide equals 33 grams divided by 12 from the 1 carbon, plus 16 from one of the oxygens, and 16 from the other oxygen. We don't do 2 moles, because remember it's the mass of 1 mole of carbon dioxide. 1 mole of carbon dioxide is 12 plus 16 plus 16. And if you do that on your calculator, you get 0.75. So that's the number of moles of carbon dioxide that's produced in the reaction, in this question. The question is asking us, if we make 33 grams, which remember is 0.75 moles, what mass of ethanol do we start with? Let's step back a bit and let's look at the number of moles of ethanol that react to produce 2 moles of carbon dioxide. We've got an invisible 1 here, let's just add it in for clarity. So what we're saying is 1 mole of ethanol produces 2 moles of carbon dioxide. That means if we started with 2 moles of ethanol, we produce 4 moles of carbon dioxide. If we started with 18 moles of ethanol, we'd produce 18 moles of carbon dioxide. If we produced 2 moles of carbon dioxide, that must mean we started with half that, 1 mole of carbon dioxide. So the next step, step number 3, is to look at reacting ratios. And when we look at the balanced equation, we find it's a 1:2 ratio for the substances that we're interested in. Given that it's a 1:2 ratio, we remember that we actually started, in our question, we produced 0.75 moles of carbon dioxide. And that's 0.375 moles. So what we're saying is 0.375 moles of ethanol reacted to produce 0.75 moles of carbon dioxide, and remember our 0.75 moles of carbon dioxide is the same as 33 grams of carbon dioxide. Nearly there? Step number 4 is to, now that we've got the number of moles of ethanol that reacted to produce this number of moles of carbon dioxide, if we've got the number of moles of ethanol, we can work out the mass of 1 mole of ethanol. That means we can work out the mass of ethanol. So let's see if we can do that. So here we go. We've got 0.375 moles of ethanol equals, that's the number of moles, equals the mass divided by the mass of 1 mole. Here's the mass of 1 mole. From the formula you can see you've got 2 carbons. There are my 2 carbons. You've got 6 hydrogens. There are my 6 hydrogens. And you've got 1 oxygen. There's my 1 oxygen. And when you work that out, you get the mass to equal 17.25 grams. So what we're saying is, if we start with 17.25 grams, that's equivalent to 0.375 moles. According to this ratio, double that number of moles is the number of moles of carbon dioxide that's produced. Once you've got the number of moles of carbon dioxide produced, you can relate that to the mass, and there's where that mass came from. Okay? Hopefully that makes sense.